Right, now one thing we might want to do at this stage is start optimizing a bit our plane, and to do this we'll run another design with just the original AG25 foil. So just to avoid confusions, I'll rename this plane to AG25 mod, and we can check that this is correct by displaying the foil names. So we have the AG25 modified at each span location here. Looks good. So let's make another plane from starting with this one and by modifying it, and we'll just modify the foils at each span location. Okay, and here's our new wing with the original AG25, and we'll give it another color to make it distinct in the 3D view and avoid confusions. Save and close, save and close. Now we don't want to overwrite the first plane, so we'll save it as a new one, and I'll give it this name, AG25 from Mark Dreller. Okay. We now have two planes which are listed in this box here, and we're going to run the analysis of this second plane exactly as we did for the first one. So I'll switch to the polar view, define the new analysis, leave everything unchanged, and the program has kept in its memory the parameters we set for the first analysis, so I'll know this is exactly the same parameters and things will be comparable, and we run the analysis. Right, so what do we see? This plane has a bit more lift, which makes sense because if you remember, we reduced the camber when we modified the AG25, so we should have less lift, and we should also have a plane which is slower than the one with the modified AG25. Basically, less camber means less lift, and therefore more speed to balance the weight. So if we're looking for, let's say, a fast sail plane, we'll be targeting this kind of curve here. If we're looking for a slow bubble dancer, well, we're going to target this kind of curve here. But in all cases, we'll try to minimize the drag, the viscous drag, and the induced drag. And well, that's how it goes, and you can run as many analyses as you can and try to optimize your design from there. At this stage, we've only used the overall mass property of the inertia. We didn't really look at stability behavior, and that's what we're going to do at the next step. Okay, let's save and move on to stability analysis, because it's nice to have a very good sail plane with good performance, but if it's not stable, it will just not fly, so we need to optimize both things at the same time.